Imagine this. You sit down to a test, and the very first question is a system of equations. Two lines, two variables, and your brain freezes on the wrong thing. Should I use substitution or elimination? Instead of how do I get this done fast? In this video, the hesitation disappears. You will learn how to look at a system for literally 5 seconds and know instantly which method will be faster, cleaner, and way less error prone. If you see something like y is equal 3x plus 2 and 2x minus y is equal 7, you will know on sight whether to isolate and plug in or line up and cancel. Here's the goal. By the end of this intro, you are not just able to use the substitution and an elimination, you're choosing between them like a pro, the way you pick the right tool without thinking. You will see real examples, from simple equations to ticket and phone plans problems, where choosing the wrong method wastes time, but the right one makes the solution almost automatic. So if you're tired of guessing, stick around, because in this lesson you're getting the 5 seconds decision checklist that you can use on every system you see from now on. Hello everybody, hope you're doing well. My name is Untitled, and again welcome to my channel Special Case. Today, as I promised, we are going to talk about a very interesting topic that somehow is following section of previous subject, and it would be about pick up the right method in 5 seconds in order to find the solution of two lines intersection, or maybe some of you as two equations, two unknowns. So at this point, we are going to consider two common ways that we are using in order to find a solution for the intersection of two lines. As you just know, the two lines either are going to have one intersection, no intersection, or are going to have unlimited number of intersections. So we are going to follow the two methods, one is substitution method and another one is the elimination method, to see that which one is going to be best. And I'm going to give you 5-second step that you can completely understand which one is going to help you to answer your question faster. At the end, remember, it doesn't matter which way you choose, the substitution or elimination method, at the end, your numbers should match completely together. So as you can see over here, I do have two different equations, y is equal to 3x plus 2 and 2x minus y is equal to 7. So the real question is, which method should I choose and why? So at the end of this video, we are trying to know how to solve the system of linear equation algebraically. We are trying to decide when to use the substitution or elimination. We are going to align and scale equations to set up an elimination. We are going to solve mixture, cost, work, and tickets, and all in all, real world problem. And the key idea over here is that different systems, they are going to have different best method itself. So again, as I just told you before, we do have three kind of condition when we do have two equations. As you guys remember, y is equals mx plus b is going to represent the equations related to a specific line. So if we do have two lines, we are trying to find if they do have any kind of intersection together. Either is going to be yes, how many is going to be one, or unlimited, and the question is no when both of them are in parallel. For instance, as you can see over here, I do have two equations. 2x plus y is equals to 7, x minus y is equals to 1. As you guys remember from the previous video, by the way, for those of you that don't know what's going on right now, it would be better to check my previous videos. Just remember, as I'm going to put the link over here, remember two lines and their intersections. You can completely understand what's going on over here. But just in case, I will explain everything for you to have some idea that what I'm talking about actually. So as you guys remember, I all the time tell you, try to make your lines equation something like this. Y is mx plus b. M is the slope and b is the y intersection, or it means that at what point some kind of your line is going to start its work itself. So I do have y is equals mx plus b. So how I can do that over here? Easy, just move 2x to another side. So I do have y is equals 7 minus 2x, so negative 2x plus 7. And at this point, I do have y is equals x minus 1. So I do have this -2 and I do have this 1. As you guys remember, if I do have two lines and if there is some slope is going to be different, for sure you can say that they do have one intersection. If their slope is the same but their b or y intersection is different, you for a fact that they are going to be parallel, so you don't have any intersection at all. And if those some kind of linear equations are going to be exactly like each other, for a fact that those lines are going to have intersection all the time, overlapping each other. So at this point, I do have different kind of slopes. I do have different intersections. So for sure, I know there is going to be one and only one answer. But here's the real question: how I can find it? Which method is the best? Stay tuned and you can completely understand what's going on. So let's go over to the next part. And the two very main algebraic methods in order to answer this problem itself. So again, try to imagine what the real problem is. I do have two lines. I want to know that do they have any kind of intersections? If yes, one or any, or if no, it means that they don't have any intersection at all. So one way that we talked about it before in the previous subject or in the previous some kind of videos, what about the substitution method? Substitution method means that you do have two equations. If you can write down one equations or some kind of, I can say one term or one unknown based on another unknown and keep that, put it into another equation, you can solve the problem itself. It will be better to explain to you using an example. Imagine that you do have this equation. You do have y is equals to 2x plus 1, 3x plus y is equals to 19 itself. So at this point, I know for a fact that these two guys are going to for sure have an intersection. Why? Because if you rearrange that, you will understand that the slope of this guy, m, was 2, and the slope of this guy is going to be -3. So here's the real question: how I can find that specific point? Again, what is that specific point? It contains two parts, x and y, and we know for a fact that on that specific point, two lines are going to have intersection. Or if you find 1x and if you put it inside of these two of equations, it doesn't matter which, at the end you're going to have the same y or have the same intersection. So let's see. So at this point I can see that y is equals 2x plus 1. It means that my first unknown is written based on the second unknown. So I'm going to use this one and put it inside the second equation. Guys, remember that I saw it so many times that they're going to find that equation, the very first one, write one term based on another term, and after that put the exact same concept into the exact same some kind of equation. If you do that, at the end you're going to reach to 0 is equals to 0, which is a fact. So you're not adding anything new. So remember, you have two equations, find one unknown based on another one, put it into the second equation. So my y is equals to x plus 1, and right now instead of y I'm going to put 2x plus 1. So my 2x plus 1 is equals to 19. So maybe some of you would ask why we're doing that. So obviously when we are talking about equation, a linear equation or one unknown equation, I need one unknown, I need one answer, one concept. If I do have my equation as the way it was, 3x plus y is equals to 19, I do have two unknowns, one equation, so I cannot solve it. Yes, maybe I can put some random numbers, but imagine that you are at the exam, and so you don't have the time to put all of the numbers, and the numbers that you're thinking maybe would be very far from the numbers that actually are, because numbers could be some kind of decimals, could be positive, negative, so there are numbers that you can't even imagine that. So we are going to use these two ways. Right now we understood that how we can use the substitution method. By the way, don't worry, we are going to solve a couple of questions and I'm making sure that you guys completely understand it. So I do have my 3x plus y is equals to 19. I just found out that I can write down y based on another thing, based on my previous information. Y is 2x plus 1, so 3x plus old y, which right now is 2x plus 1 is equals to 19. Solve this equation, you will find the x. You will find the x. Am I done? Obviously not, because I have to put this x inside one of these equations. This is the fun part, because it doesn't matter which equation you use. Either you use the y is equals to x plus 1, or you're using 3x plus y is equals to 19. You put this found x into that equation, and after that you solve that one. For y, you will find the y. So at this point, you have your intersection, which is x and y itself. So another point would be, or some kind of way, is about elimination. What does that mean? Elimination means that you do have two equations still, but you see some kind of patterns here. Just before that, let me talk about a very easy law, some kind of rule or law that we saw it maybe hundreds of times, but we haven't actually talked about it, or we haven't really focused on that. Imagine that I do have my a plus b is equals to c. After that, d plus e is equals to f. We do have a rule, or we can do it like this, that if I add plus everything over here, left side of this equal, and if I add and this guy together, at the end I can have a plus b plus d plus e equals c plus f itself. So let's see with numbers. For instance, 2 plus 3 is equals to 5, 3 plus 7 equals to 10, right? Either I can have this, or I can combine those. So I can have 2 plus 3 plus 7 equals 5 plus 10. I do have 15, I do have 5, I do have 10, and I still have 15. So it means that I can actually add those sides, or add those equations based on the left side by left side, right side by right side. So maybe one of you ask why we're trying to do that, because at the end we are going to have the third equation, and we don't need that. We are going to make everything complicated. Yet, if you look at this equation, you can see that apparently I do have positive y and I do have negative y. So if you guys remember, while we were rearranging all of the equations, we were trying to move one specific thing, could be constant or variable, from one side to another side, and we use the inversion method. It means that if I do have positive y, I want to use the negative y, but I have to make sure I do it for both sides, because again, I don't want to lose my balance. So I do have negative y, but still I have to use it there. So let's think about why we're doing that, because we won't like to eliminate something, right? Yes, I know for a fact that when you eliminate something from one side, you have to add it from another side. Well, what would happen if we don't have to think about another side, and we have to only shift our focus on the first side? Like this point, I do have positive y. For another equation, I do have negative y. If I add those, apparently I can get rid of y, and there is no y around after that. So the only thing that is left would be x. So I can solve for x, and after that I can find the number itself. Like this one. If I add these two, if I add all of the left sides, and if I add all of the right side, I do have 3x equals to what? Because this y is going to cancel out this one, 8. And my 8, it's x, it's 8 over 3. After that, I can put it in one of the equations, and I can find y. Simple as that. Maybe some of you would say that apparently this method is way faster than the substitution method. Well, why we can use it all the time? Remember, not all of your equations are going to be simple like this. Some of them are going to be a little bit challenging. They do have different coefficients. The only thing that we had over here was 1 and negative 1. It was simple, right? But at some points, you have to do a couple of things in order to convert it to the thing that you like. After that, apply the elimination, or maybe use the substitution. The good thing about the substitution method is actually the only thing you have to do is just find one variable based on another one, put it inside another equation, and bam. But for elimination, you need some kind of condition to do that, and I will talk about it, why and how. So first of all, let's talk about the substitution method. Again, it's a simple one. So what you should do, as I just told you, use one equation is already solved or almost solved for a variable. It means that you have y is equals to x plus 5, and you have some kind of x subtracted 3, y is equals to 4. So at this point, you can write down your x based on y and whatever concept is there. And this question, there's some kind of, this part is easy because it's already written that. So you don't have to worry about it. So these are 5 steps that how you can do that for your substitution method. Again, solve one equation for one variable, the thing that we just did over here. Substitute into other equation. Remember that this is other equation. We have to use another one as well. We have to use everything that we have in order to find the answer. It means that as soon as you find your x, just put it over here. Solve for the remaining variables. It means that the only thing that I have right now is 2x plus 5 over here, right? Which is the old one. But as soon as I put 3y plus 4 over here instead of x, I would have y equals 2 times 3y plus 4. After that, what? Plus 5. So I only have one variable. It means that I can solve it. And the second step there, some kind of the fourth step, is plug back into to find another variable. It means that I will find y something. For example, y is equals to 2. I don't know. Y is equals to 2. So at this point, the only thing I have to do right now is either put it inside this equation,
or this equation in order to find my x, and checking both equations. So the final step is a very important key step. It means that you have to double check your answers. As soon as you found your x, your y, you can find another variable based on that. But here's the real question. Is that specific point, or is that specific x and y is going to be right for all of those equations? So you have to check it. Take your time, completely check it, because it is common that you maybe forgot one coefficient, some kind of positive and negative, and you found one x and found one y. That is okay, but is that x and y actually matters, or actually the thing that I'm looking for? So be careful about that. So at this point, we had the substitution is going to replace as one variable with an expression, the thing that we just had before. So let's see a couple of some kind of examples, because we would like to do as many examples as we can, and after that we want to make sure that you completely understand. So I'm telling you right now, try to pause the video, think about it without just looking at the answer itself. Pause the video, look at those equations. We do have y is equals to x plus 1, and we do have 3x plus y is equals to 19. Think about those two and only think about the substitution method. It means that you have to find one variable based on another one, put it inside another some kind of equations, find one variable, and after that put it inside either of these equations, and you can find your final number itself. So let's just solve this equation together, and we remember we are going to use the substitution method. Y is equals to x plus 1 and 3x plus y is equals to 19. So this is not that hard because y is already written based on another variable or based on x. So the only thing that I have to do is to put whatever that I have over here instead of y, and after that solve everything for x. So I do have 3x plus 2x plus 1 is equals 19. So adding the like terms, 5x plus 1 is equals 19, and after that I do have this 1 should be moved over here. 5x equals to 18, so my x is equals 18 divided by 5 itself. So I do have something like this. Again, remember, not all of your numbers should be beautiful, like 1, -1, 2, 3. Sometimes your number are decimals or fractions. I recommend my students try to get rid of fractions and finding the decimal one. For instance, 18 divided by 5 could be something around 3 point something, I'm not sure right now, and use that one in order to put it to find another variable, because if you have one fraction and put it on another side, it would be a little bit ugly. It would be better to get rid of that as soon as possible. So right now, so far, I found my x. So the only thing that I have to do, if you remember based on the previous step, is that I put it inside one of those equations. Again, it doesn't matter what equation I'm using, and after that I can't find the y. At the end, I know my x and y are going to be right itself. So let's choose, for example, like the answer over here, I'm going to choose y is equals to x plus 1. So y is equals 2 times the new x, which is a number, 18 divided by 5 plus 1. And if you do this calculation, your final answer would be 41 over 6. So my y, I do have my x. Again, remember, you have to check it with your some kind of these equations, that if I find a point x and y, these points should be accepted or should be applied into both of these equations, and at the end a y or x that I'm getting outside of each of those should be the same itself. So right now the number is a little bit ugly, as I just told you. Try to make it decimal, and at the end you probably going to have a little bit of difference. That's okay. For example, it's around maybe 1% or 0.5% difference, which is caused because, for example, 41 divided by 6 is not exactly the number, for example, 4.2. It could be 4.2, 3, 5, 6, whatever. So you're not using all of the decimals, right? You're going to use a 1, 2 at the very top and precise moments, 3 of those decimals. So your final numbers could be equal and could be the same itself. So let's talk about the real world. If you guys remember, for the previous slides, we were talking about the phone bills and about the phone plans. And I told you that find that specific point that if I imagine the x is going to be the gigabyte that I'm using and the y is going to be total cost, and I do have these two plans, it means that my first plan is going to start with the $10 beforehand, and after that, based on each gigabyte, I have to pay $5, and my second plan is $25 at the beginning, and I have to pay some kind of $3 per gigabyte after each using of each gigabyte. So maybe for some of you is saying that this is going to be useful. I'm saying yes, 100%. Why? Because imagine that you're going to do different operators and you see that one of them is costly at the beginning, and probably I can find a value in that. How? You can find the specific point that these two lines are going to intersect. First of all, how am I know that these two lines are going to intersect? Because as you can see over here, they do have different kind of m's. So, or different kind of a slope. So for sure, I know they're going to have intersect. But here's the question: if I find that intersect, so what am I going to do with that? If you find that specific for or that specific intersect, like the visualization over here, you see that while the second plan is going to be costly at the beginning, but after intersection or after this point, this guy is going to cost a little bit. It costs less than this guy. So right now, you just found economical solution for your phone bill. Because if you choose the second one, yes, at the beginning of the point you have to pay a little bit more, but in the long run, that some kind of beginning of the point is just a one-time fee. But in the long run, you're going to save more and more. And if you try to continue this one, it would be something like this: goes up, but this guy goes something like that one, and you're going to save tons of money in the long run itself. So here's the question: where is that specific point? After how many gigabyte usage I'm going to find that, or I'm going to reach to a point that these two plans are going to cost the same. So let's find that. I'm going to use the substitution method. I do have 10 plus 5x for one, and 25 plus 3x is equals to another one. This one is simple because I don't have to do anything at all. Y is already there and another y is already there. So the only thing that I have to do is just put whatever that I have over here. So at the end, I do have 10 plus 5x is equals 25 plus 3x, right? If you rearrange that one, it would be 5x subtracted by 3x is equals 25 subtracted by 10. So I do have 2x is equals 15 and x is equals to 7.5. So what does that mean? It means that after using 7.5 gigabyte of usage, both of these two lines are going to have intersection. So here's the question: what is that specific money that I have to pay after 7.5 gigabyte, which means that it is going to be the same for both of them, right? So the only thing that I have to do, I just put this number inside both of those equations, and I do have $47.5 at the end. So plan A is going to be cheaper when I'm using less gigabyte, because some of you maybe say that I'm not going to use more than 7 gigabyte and it doesn't make any sense for me to use the second plan. Or some of you would say that no, I have to use more than that. So I have to see my condition, that at which stage am I in right now in order to find it, because the best solution doesn't exist. The solution, or the good solution, is related to your condition. So at this point, I see that if I'm losing less than 7.5 gigabyte, it doesn't make any sense to come up with the second plan. But if I'm using more than that, it would be better to come up with the second one. It's completely based on your condition. That's how you're working in the real world. You're learning mathematics, not only going to be some kind of successful in our school, in a college, and etc., but also be successful in our own life. So that was some kind of question related to some kind of substitution. But right now, let's talk about another big method. That why we are saying that it's a big method, because this method seems simple at the beginning, but it's going to be a little bit challenging at the end. Why am I saying that challenging? Because sometimes it's not going to be the thing that you see. Sometimes you have to do a couple of sacrifices, or I have to say you have to do a couple of multiplications, some mumbling and jumbling in order to reach to the point that one of your variables could eliminate another variables using two equations. So let's see about that. So when we're using this kind of things, when both equations are in standard form, it means that ax plus y is equals to c. We are using on that time. Why? Because it's going to make more sense if you do have that, because at that point we can add up both sides. The left side would be about variables and the right side would be about the constant, and the coefficients should line up nicely. It means that if one of them has positive 2y, another one should have negative 2y. If one of them is 7 over 5y, the other one should be negative 7 over 5y. Because what is going to be the reason for you if you cannot eliminate one of them while adding up those or maybe subtracting those equations? Because at the end, I'm trying to simplify something. I'm trying to write down one equation, one unknown. If everything is going to lead to the fact that I'm going to make everything complicated by coming up with a third equation, what's the usage of that, right? So these we do have 6 different steps. The very first thing is that align like terms. It's going to be x under x and y under y. What does that mean? Imagine I do have x plus y is equals to 7. If I'm going to use the elimination method, the next one should be something like this. 7x subtracted by y is equals to 8, for instance. So I have to have something like this. Why? Because at this point, I'm going to have a little bit simplified version. Y plus negative y, eliminate x plus 7x and 7 plus 8. That would be better. multiply one or both equations to make opposite coefficient for one variable. So this is the part actually you have to use some kind of knowledge, or you have to use different kind of method in order to find a specific point. Why we are saying that, imagine that we do have these equations. I do have my 2y plus 3x is equals to 10, and I do have y plus 4x is equals to 5, for example. These are completely hypothetical. We are going to see lots of questions. So at this point, when you look at the equation, you see that using the elimination method doesn't make any sense, because it doesn't matter if I add them or if I subtract them. By the way, subtraction means that you when you can add both sides, the left side together, you also can subtract them together if you make sure that your right side are going to be subtracted by each other. So at this point, I see that it doesn't make any sense if I add them or if I subtract them. At the end, neither of my y nor x are going to be cancelled. So what is the usage of that? But I'm telling you that at this point, I do have a way. What is that way? What would happen if I tell you that I do have a number that if I multiply it by the second equation, I can make y's just like each other but with different sign, and you can use the elimination. And you say that, oh, let's do it out of curiosity, right? So I do have y plus 4x is equals to 5. What would happen if I multiplied both sides, by the way, when I'm saying both sides, by -2. By the way, when I'm saying that I can multiply or divide both sides or subtract both sides or add both sides by one number, it means that I'm not losing any balance, right? We all remember from previous subjects. We are not losing any balance. We are trying to just convert one thing to another. We are not scaling it up or scaling it down. Because the scaling up means that, for example, you have y is equals to 10, and after that you have y is equals to 20. You are scaling it up. But right now, my y is equals to 10, and after that 2y is equals to 20. So I'm not losing anything, right? 2 can be cancelled by 2, and at the end I still have my own equation, right? So at this point I'm doing that because I would like to use it for something. So I do have -2. Remember that these guys should be multiplied by all of the things, and this one like this. So you have -2y subtracted by 8, so subtracted by 8 is equals to -10. So right now you look at it and say that makes more sense, because I just convert y plus 4x equals to 5 to -2y subtracted by 8, 8x is equals to -10. Why that makes sense? Because right now I can use the elimination method. How? There's -2y plus +2y, those things are going to cancel out each other. 3x subtracted by x, these two things are going to cancel out each other. And after that, my 10, and this is the fun fact, it was completely out of blue. So 10 is also can cancel out the -10. It means that my x is equals to 0. So if the x is equals to 0, the only thing you have to do is just put the 0 into one of those equations and you can find a y. Simple as that. Because sometimes this funny thing could happen. It wasn't scripted. It was completely rare situation that you have something like this. But this is one of the privileges of using the elimination method. So after that, we have to do the add and subtract equations, which I already did. Solve the new one variable equation. This is step that's just like the previous one. Back to substitute to find another variable. And after that, check in. So remember, the last step at this point, the 6th step, and for the previous one, the 5th step, is the very important step. Why? Because at the end, when you find any x or y or any other kind of variable, because as I just told you, x and y are just names. It means that not all the time your variables are going to be x and y. Sometimes it's going to be t and z, sometimes c and b. I don't know. They could be changing. But y is mx plus b is a very common way of talking about one specific equation. So at the end of the day, when you find one variable, you have to make sure that it doesn't matter if you put it into what's first equation or second equation. At both of those times, the same the y or the final variable that you get out of outside of both of them should be the same. Rather than that, your answer is wrong and you have to redo everything to make sure that whatever was the actual problem. So again, the key idea or the goal is to make one variable disappear so you can solve some kind of one variable based on another one. This is the exact same idea that you use it for the substitution, right? If you remember, we are trying to write down one variable based on another one, put it inside the second equation, and bam, get rid of one of the variables. This is the exact same thing we are going to do, but with different kind of method itself. So let's see an example. Aligning and scaling. By the way, again, remember when I'm saying that we are scaling something, it doesn't necessarily mean that I'm scaling it up or scaling it down, because if I say that scaling up or scaling down means that I'm increasing or decreasing one number. The only thing that I'm doing, my equation was like this. I'm going to do it like that. I'm going to do it like that. Still have my equation. Nothing changed at all. So we are going to use this one. So let's solve another example based on the elimination method. So at C actually contains a couple of examples. So let's start from this one because we're not going to get confused. So I do have 2x plus 3y is equals to 16, 5x minus 3y is equals to 4. This is just in a perfect form. I do have a constant on the other side, and I do have a couple of variables on one side, and the second one as well. So the only thing that I have to do, I have to add them up. Y, positive 3, negative 3. Bam, they're going to cancel each other, right? So add them up. This guy is going to cancel. So I do have 7x equals to 20. My x is equals to 20 subtract divided by 7. This is the first thing. So the second one means that I have to put this value, whatever is that, into one of these equations. This one doesn't matter, and at the end I can find my y itself. Simple as that. So another point, I do have 2x plus 3y. Actually, this is the same example. So imagine that I do have something like this. This is the beauty of that. So right now, when you just look at this equation, you see that it's not very good. I cannot use some kind of elimination method, and it would be better to use the substitution, right? And I would say that try to think a little bit better. So right now, when you look at it, and 2x plus 3y is equals to 16, and 5x plus y is equals to 4, what is the thing that you can use? Because converting 2x to 5x would be a little bit challenging, but converting, and also 5x to tx is going to be challenging because you have to multiply by some kind of 2 over 5 in order to do that. 2 over 5 is a fraction. We don't like it that much. But right now, y can be converted to negative 3y. Remember, negative 3y is something that we need. Let's do it. So negative 5y to negative 3y means that I have to multiply everything by negative 3, right? So multiply this part by negative 3, and at the end I do have this. So, and this guy are my main focus right now. If I add them up, that would be good. Positive 3y is going to cancel out the negative 3y. So I do have 2x, and this guy can be subtracted, or can be some kind of adding up with the 2x itself. So you have negative 13x, and 16 subtracted by 12 is going to be 4. So right now you can find whatever value you had, x, and put it, and after that you can find the y itself. Simple as that. Let's see another example. 3x plus 2y is equals to 7. 5x minus 2y is equals to 13. Simple. The only thing you have to do, you have to add these two sides. Again, try to write it down like this. That would be way better because you can all completely see that what is happening to y. These two things are going to cancel each other, and at the end you have 8x is equals to 20. So you can find the x, whatever is that, 20 divided by 8. And after that, you can find the y itself. And simple as that. Again, remember, you have to verify the solution. Means that whatever x and y you found, you have to put it inside those equations and make sure those equations are going to be right itself. So let's talk about special cases, because as you just remember, we had three kind of different conditions. The very first condition that we have, which we are going to use the two methods in order to solve this equation, was related to the fact that I'm going to have one and only one intersection. But if you guys remember, I told you we also do have two other situations again. It means that either I don't have any answer at all, or maybe I do have unlimited number of answers. So what's the point of solving some kind of this elimination or substitution method? Because at the end I know I don't have any answer, or I do have so many answers. So what is the point of that? It would be better to, at the beginning of the point, I do have some caution and make sure that I know the future, or I can predict the future just beforehand. Let's see what I'm actually mean. Imagine that I do have two equations and I'm doing all of the substitution methods and everything works fine, but I reach to something strange. And what is this strange way? It means that I reach to something like this. 0x plus 0y is equals to 5, and at the end I reach to something like that one. What does that mean? 0 obviously it's not equal to 5, so at this point it means that I don't have any solution, or they have parallel lines. So what does that mean? Imagine that I do have y subtracted by 2x is equals to 5. And after that, I do have y plus 5x is equals to 7. Imagine that. I'm sorry, that was completely bad. Still have to fix it. Yes. Imagine, let me give you something like this. Why, at what point that two things are completely parallel with each other, if both of them are going to be the same, right? Something like this. Y subtracted by 2x is equals to be 7, right? At the very beginning of the point, when you just look at it, you see that something is off. Yes, I know, because if I want to eliminate the y right now, the only thing that I have to do is multiply by negative 1, right? Both sides of this. So what would happen? Y minus 2x is equals to 5 is going to be the same way that it was. and negative y plus 2x is equals to negative 7. So at the end, this guy is going to carry this guy, cancel out this guy, and 0 is equals to negative 2 itself. And you would say that it doesn't make any sense. 0 is not negative 2. So you know that there is no answer because there is no 0 that is equals to negative 2, or any other kind of different numbers are not going to be equal to each other, right? So at the beginning of the point, you should saw that. But it doesn't matter because sometimes professor would ask, prove it to me. So how you can prove it? Simple. Use the elimination method or use the substitution method, and at the end you would reach to something like this. After that, we do have another thing. At the end, we reach to this fact that 0 is equals to 0. It means that always true, so you have infinite number of solutions. This point is important. Why? Because for some of you, if you guys remember, I told you about that. You do have two equations, you do have two unknowns. Based on the substitution method, you are going to find one variable based on another one and put it inside the second variable, inside the second equation, sorry. But at some points you will forget that and you say that, okay, I'm going to put it in one of the equations, and just randomly you forgot about what equation actually use, and you're going to use this exact same equation. And at the end you are going to reach to 0 is equals to 0 and say that, hey, this is the infinite number of solutions. So you're very careful. When we are talking about 0 is equals to 0, it means that when you find one equation, one variable based on another one, and if you put it inside the second equation, or if you do the elimination method and you reach to 0 to 0, on that specific point, we mean that we do have infinite number of solutions. What is the way to some kind of don't have this problem? Just look at the whole thing at first glance and try to some kind of imagine or try to remember y is equals to mx plus b in your head, or maybe on the paper, and to see that if you don't have the same m's, or if you don't have the same slopes, it means that 100% you do have one intersection. But when you see that the slopes are the same, or slopes and the b or intersection are the same, so you would be a little bit curious that something is going on over here that I don't know. So it means that if 0 is equals to 0, if you do the elimination method and you find out that one, it means that you have unlimited number of answers itself. So how we can see that? For instance, I do have something like this, that y plus 2x is equals to 5, 2y plus 4x is equals to 10. So right now, imagine that I don't know anything about the slopes. I don't want to find it as y is equals mx plus b. And even the professor said that, okay, prove it to me that this guy is going to have unlimited number of answers. How can I do that? Again, try to find the elimination method. So if I can find a way to convert y to 2y or y to negative 2y, because at the end I'm going to eliminate both of them together, right? How can I do that? So multiply both sides by negative 2. Let me use another color. So I do have negative 2 times y, negative 2 times 2x, and negative 2 times 5. I would have negative 2y subtracted by 4x is equals to negative 10. For another one, I had 2y plus 4x is equals to 10. And so this going to give 0 goes to 0. So I know for a fact that right now I do have unlimited number of answers. Simple as that. Needs practice. And by practice, you can make everything perfect. So that was this part, and after we would reach to the fact that, as I just told you and as I just promised, we had, first of all, it is very important. First of all, you have to know that at what point you have to use these kind of methods. As I just told you, we do have three kind of conditions: no parallel lines and overlapping each other. So on the second point, it means that you are going to have one intersection for sure. Right now, I have to use one of these two methods. But here's the question. The real question is, which one of them would be a little faster? So I came up with some kind of 5-second method that you can just look at it. Maybe if you want, you can memorize it. But at the end, it's completely based on your idea and based on your comfort zone. Maybe some of you have so much practice over one way and say that I like this one way more. But I recommend you to have enough practice over both of those equations. Any kind of two equations you see, try to solve it based on two equations. That would be way better because you are developing your mind. And then sometimes maybe at the college or university or the school, there's some kind of your professor ask for a specific method. So if you just do it with another method, the only thing that you get is the final mark based on the right answer, not based on some kind of way or your calculations. So let's look at it. Do you see any y is equals to blah or x is equals to blah already? So if you see that you have this one at this point, it would be better to use the substitution method. Why substitution method? Because if you guys remember, I told you, when I do have one variable based on another one, the only thing that I have to do is put that specific variable into another side. But by knowing the fact that the new variable is going to be based on another variable, so that would be very simple. I don't have to move all of the variables in one side and after that all of the constant on the other side, just like the way that I told you. You remember, it would be better to use ax plus by by is equals to c. If you're sure that your first equation is and your second equation is based on that, that way would be way better for elimination method. But when you have something like this, x and y is already defined based on another term, based on another variable, that would be way better to use the substitution method rather than elimination. So the second one, are both equations in a standard form with nice coefficients? Use the elimination method. What was some kind of standard method I told you? The standard method is like this. Maybe some of you would say that you also mentioned that this method is a standard form. Yes, this method is also, some kind of equation is also standard form, but the real thing that we are looking for is ax plus by is equals to c. This second form is way better for this some kind of the substitution one. So remember, when you do have x plus by is equals to c for both of them, a1 like this, a1x plus b1y is equals to c1, and a2x plus b2y is equals to c2, it would be better to use the elimination. Can you make a variable cancel with one easy multiplication? Use the elimination. What does that mean? If you guys remember, if you have y for one of the equations and if I have 2y for another equation, the only thing you have to do is multiply everything for the first equation by -2, right? So it is very simple. Rather than just finding one variable based on another one, put it into the second equation, find everything by knowing or imagining the fact that we don't have any problem in this process. That way is way better. Try to find one variable and convert it to somehow that can eliminate the same variable in another equation, and you can use the elimination method. So another one that is one variable easy to isolate, use the substitution method. What does it mean that to isolate? As I just told you, put one variable, x or y, in one side and put everything that is not like that into another side. If you can do that, you're still going to reach to the first one. It means that I can define x based on something and y based on something. Using another equation, and bam, I can find everything that I need. So try to ask these 4 kind of questions for yourself. Maybe I can't do that. So these are the questions that at the beginning of the point, maybe you have to somehow memorize them, but so after practice, your eye and your brain is going to get familiar with all of this concept. Because as soon as you see an equation, you see that this method is better, and you don't even have to answer those questions in your brain, because your brain is already trained and completely know which condition is better. But at the end, it doesn't matter what way you use, because you have to find the right answer based on either of these 2 ways. So try to practice on both, not only one. So another some kind of the cost problem that we are going to talk about. This is very some kind of, I have to say, general way to talk about. If you guys remember from the previous video, we were talking about the adult tickets and the student tickets. And this is the general way to talk about that. You can just look at it, but it would be better to look at this question. So right now I changed the question a little bit. Imagine that we do have the concert and we are selling 200 tickets in total. Adult tickets is going to cost $12, student tickets is going to $8, and at the end I know the total money collected is $19.60. So let's assume that A is the number of adults and S is the number of student tickets. So let's do that. It means that at this point I have 2 equations based on the information. So guys, remember, we are not going to solve just mathematical things. Right now this is mathematical, but still it's a real world problem. So your job as someone that will completely understand everything, especially about the subject or any other kind of related subject to chemistry, anything, is to have the ability to convert words into calculations. Solve the calculation and find the answer. So in the future, if you want to use it in your real life, into your science, into your major, whatever, you have to have the ability to develop your brain to use all of the knowledge that you have. Because the very famous question that I had while I was at some kind of school and university was that we do have the concept in the name of integral. So integral is a very advanced topic, and when you just look at it, you say that, oh my God, why should I some kind of learn that? Because I know in the future, or maybe my dad or some kind of uncle just told me that you're not going to use integral in your real life. Just do this some kind of multiplication and addition and subtraction is fine. That is okay. But I remember one of the quotes from a great professor that says that we are not learning these kind of stuff. This kind of stuff that we are learning are very crucial. But other kind of advanced stuff, we are not learning advanced stuff in order to use them in our real world. We are learning them because we are trying to develop our brain in order to solve any kind of problem that are unpredicted. So imagine that in your life you do have some problem. It doesn't mean that it should be calculation problem. You have to have some tough decisions. So by learning by knowing how to handle all of these tough situations, and by seeing everything, you're just like a hawk. And you can just look at everything while you're looking at your brain and say that at this point, substitution method is good. At this point, elimination is good. At this point, I shouldn't even do that. Why am I trying to do that and some kind of have my life, because I do have a short amount of life, because I cannot do everything that I want. So that was some kind of outside of the scope, but try to learn everything that you see. Not everything, obviously. Try to learn everything that you are passionate about and use them. And don't say that I'm not going to use that in the future. Just try to learn and develop your brain, because the more you develop your brain, the better person you can be in your personal and professional life. Let's back to the question, enough talking. So I do have 200 tickets. It means that my A plus S, is adults plus a number of student tickets, is going to be 200, right? This is the first equation. So I do have A plus S equals to Y. And also I know that each adult ticket is going to be worth $12. 12A plus 8S is going to be 1960. So again, as you guys remember, I told you that not all of your numbers or everything that all of your variables are going to be X and Y. Sometimes it's going to be A and S. So at the end, I do have this equation. So when I'm just looking at it, I see that I can use the elimination method, or I can use the substitution method. So I can use the elimination method. Why? Because these two are somehow completely the same. They have the same structure, right? First variable plus another one is equals another thing. First variable plus another one is another thing. So how can I eliminate one of them? Easy. I can multiply everything by -8 over here. Why? Because if I do have -8s, and 200 times -8, by the way, if I do have -8s, this guy can eliminate this guy, and at the end I do have 12a and -8a, which would be 4a is equals 1960 subtracted by 1600. So at the end, what do I have? I do have my 4a is equals to 360, and I do have a as 90. If I put it in the another equation, my s would be 110. And if I want to check that, put a and s into inside in both equations, and you see that your final answer is right. As simple as that. You just converted one word problem into two equations, which is somehow mathematical equation or algebraic equation. You just know the fact that elimination is one of the methods because you saw the structure, you saw the concept, use that, and after that solve the question. As simple as that. There's nothing wrong. Again, you still can use the substitution method. You can pause the video, use that. At the end, you still have to have the same answer. The way that I'm giving you is better. Why? Because I know this way is going to be faster. At the end, we are trying to make everything simplified, make everything faster, right? So there are some kind of common mistakes and how to avoid them. The very first thing is misaligning the terms of elimination. Remember, always line up X and Y into the constant vertically. Remember that. Another thing is about the sign errors, which I guess I mentioned millions of times. Remember that your signs should be right while doing addition and subtraction. You're going to some kind of forget to substitute back. It means that for the second variable. So it means that your final answer must be a pair of X and Y. So when you find the X, remember, when you find one variable less than another one, use it into the second equation. And at the end, when you find a variable, for example, X and Y, try not to stop. You still have one way, you still have to go further. So how can you do that? You just put that specific variable inside one of those equations and you can find the final answer. And at the end, not checking. So this is the double check problem. Whenever you find your X and Y, make sure to check both of those answers inside each of those equations. And at the end, you should have the same number itself. So try to avoid all of this all of these problems. And this is some kind of guided this is practice ideas. You can read it out. Just you still have that 5 second or still have that couple of equations. And remember, practice makes perfect. This is some kind of the real world connection. You have some kind of the complex system because sometimes you have 3 different kind of solution and you can apply this one in business, science, engineering, it doesn't matter. So you still can have graphing solution. Again, if you guys remember, the previous part was about the lines and graphing, and I told you that how you can graphs and draw another one and find a specific intersection. So you should be very precise. You still can use that, or you can use this some kind of simple example, but just remember, beforehand, make sure that you do have intersection, because if you don't have any intersection, it completely unnecessary to go everything based on this elimination, the substitution. You don't even need that, right? And this is going to be the summary at the end. So guys, thank you for being here with me, and this probably is going to be 2 or 3 chapter things. So we are at the final chapter. It is related to 2 unknown, 2 equations, And if you just like that, please like and share and comment. That would be so helpful for me. Or you can share it with your friends, or maybe someone that need this kind of help. You do have a test tomorrow and you just want to share it with your other friends and students. That would be fantastic. Have yourself a great day, night, whatever. See you around.